Okay, so going back to the beginning of the section, we learned about this important formula, S equals theta R. That is something you have to memorize and remember what what variables each letter stands for. So to remind ourselves, S is for arc length, R is for radius, theta is for the measure of the central angle, only in radians. This formula will not work if you try to do it with an angle that is in degrees. So if you were given an angle in degrees, we would first convert that from degrees to radians, just like we saw up here, and then we could use our S equals theta R formula. A lot of times the angle will be given in radians, or you'll be asked to find the angle, so you'll just answer in radians. So here's just a simple, straightforward word problem application of the formula. On the homework or on a quiz or test, you might see examples that are more contextual, where maybe there's a circle park with a path that represents the radius, whatever it might be. But we'll just do a real straightforward one here so we can make sure we're interpreting it correctly. So it says the radius of a circle is 4 feet. A central angle intercepts an arc length of 12. Find the measure of the central angle. So first we'll just identify our variables. It says the radius is 4. There's our radius. A central angle intercepts an arc length of S. Remember, arc length of 12. Arc length is S. So right here is our arc length, that's S. And we're asked to find the measure of the central angle. That means we're asked to find theta. Our formula is S equals theta R. We just figured out that S is 12. We know we're looking for theta, and we were told that R is 4. And now we can just solve for theta. So how do we solve equations? Beautiful, you sounded so lovely. Good, so we'll do the inverse of multiplying by 4, which is dividing by 4. 12 over 4 is 3. And that means our angle measure, theta, is 3. The unit is radians, so we could answer theta is 3 radians. To start to try to get a sense of how big of a radian is, ideally you'll start to try to visualize angles in radians a little bit. We saw a couple that we can start comparing a little bit. We know that a right angle of 90 degrees is pi over 2 radians. So you can picture going around the unit circle. Each quadrant is pi over 2 units. And we'll talk about that a little bit more. You can remember that pi over 6 is 30 degrees. So you can picture that little angle there is about pi over 6. So you start to get some idea. We started this by defining or by recognizing that 180 degrees is pi radians. So we know that this angle right here is pi, right? So start to try to visualize a little bit in terms of radians. 3 radians, well, just as a reference, we know pi is 3.14, which means an angle of 3 radians would be just a little bit less. We saw that that's 180 is pi, so just a little bit less than this. Right here is an angle of about 3 radians. It's helpful to try to start visualizing this, but that's something we'll have to work up to as we go throughout the unit and the course. So anyhow, there's just a simple application of how we can use our formula. You'll get some more contextual applications in the homework and as we move forward in the unit.